Alright, another day, another video, Kit Jung here. We're continuing the series on the specimen paper, the new AA and AI syllabus. So this will be paper 2 of AA SL. Yeah, that's mean SL. Well, I guess I'll need a GDC. Yeah, so I'll show you how to use one when we have to. Okay, let's do it. First question. Some sphere with a radius. Find the volume. Give your answer in standard form. Okay, I think probably the formula for volume is in the booklet. If not, you have quite a lot of stuff to memorize. Oh yeah, it's definitely in the booklet under geometry and trigonometry, topic 3. So the volume is easy, 4/3 pi r cubed. So okay, this is an extremely straightforward first question. So obviously need a calculator. Times pi times 4/3. Okay, I got 8580.24 something. Usually 3 sig fig is enough, so that's 3 sig fig. If I give it in standard form, it's 8.58 times 10 to the power 1, 2, 3. 3. Okay, shouldn't be hard. Smelt it down and remold into a cone. Find the base radius of the cone, so we need the volume of a cone. So that's this in the formal booklet. By melting it down, it means the cone should have the same volume as the original sphere. We also know that the height is 14.8. So this is simple algebra. Other than the fact that you need a calculator, it's not hard at all. So just casually do it. 3 sig fig should be 23.5. Nice. Easy for the first question. Even for the standard of a first question, that's really easy. Again, as I said in paper 1, I don't know if that means the new syllabus would be easier than the old syllabus SL. Okay, so we need an actual exam to see. Chord length AB, theta, find theta. Okay, so the key, so we want to find this angle, where this is a triangle. The key is if OA is 4, OB is also 4, because both of them are radii. Then if you have a triangle where you know all 3 sides and you want to find an angle, that should be obvious. That is cosine rule. That's exactly the job of cosine rule. So cosine rule is again in the formal booklet. Let's use the one that's provided. There's 2 forms. If you go to the formal booklet, it is this form that is slightly more convenient if you want to find an angle. You can still use the other form. They are really equivalent. They're really the same, but it's slightly easier if you use this form. So you can use any form you like. The key is the angle that you're looking for has to be capital C. Then small c has to be opposite to capital C, so this is small c. Then the rest are A and B. Okay, so we just pluck numbers in. B is 4 minus C plus A. B. Yeah, I personally don't like paper 2 that much. I don't like to use a calculator that much. What's that? 2 times 4 times 4. Okay, you should get 7/32. So you do arc cosine. As a degree, can I use degree? Yeah, I didn't specify. Oh no, I need to use radian. So change that to radian. 1.35 radian. So you could set your calculator into radian, so that when you do the arc cosine, it would automatically give you radian. Okay, find the area of the shaded region. Oh, that's why they want us to use radian. So do this. So if you go to the formula booklet, there is a formula on the area of a sector. Oh, by the way, that's a sector. That's a sector. So the area of a sector, according to the booklet, is half r squared times theta, where theta is the angle of the sector. So pretty much this angle. The only thing you need to be careful is, in order to use the formula for the area of sector or the arc length, the angle theta must be measured in radian. Okay? There is no this rule for the other rules. So for example, for sine rule and cosine rule, or the area of triangle, the angle could be degree or radian. But for arc length and sector, the formula only work. This formula only work for radian. So that's why part A need you to be in radian. So obviously we need to find this angle, which is the full angle minus theta. Full angle is obviously 2 pi minus that. So use a calculator there. I got 4.93319. Yeah, for the middle of a part, you want to write more decimal places. So that should give me the answer. 0.5. At the end, 3 sig fig should be enough. Okay, next. Okay, question 3. Okay, it's about interest rate and geometric sequence. Interest rate seems to be compound interest, seems to be a new emphasis of the new syllabus. So in 2020, invest P dollars, interest rate compound quarterly. So the amount of money at the end of each year is a geometric sequence with common ratio R. What's the common ratio? Okay. Now, if you look for the formula of compound interest, which I believe is in the formula booklet. Okay, in the first page it says compound interest. So they will tell you that the future value is the present value, which is what you put in. So that's P in this question. P is the amount you put in, times 1 plus R. R is the interest rate over 100. This 100 is actually the percent sign. Over 100 means percent, so that's R percent. And then you do a K. K is the number of times you compound in a year. So if you compound quarterly, that means K is 4, because each year have 4 quarters, to the power of K, and this K is the same as that K, so they mean the same thing, they're both 4, times N. N is the number of year, okay? So if you're looking for each year, N is basically 1, N is basically 1. And so the R, the common ratio that you multiply to the money that you have, is this. And that's exactly the common ratio. That's the R. Therefore, the R, which stands for common ratio this time, not the interest rate, is 1 plus interest is 5.5 over 100 times K is 4, so it's 400 to the power 4. Okay? They want 4 significant figures. We'll do that to the power 4. Where's my power button? See, I don't use calculator that much. Okay, 1.056. That's 4 sig fig. So Laura, make no further deposit or withdrawal. Find a year where the money doubled. So doubled. So the present value was P. Double means the future values becomes 2 times of P. That's double, right? So it's 2P equal to P1 plus 5.5 over 500 to the power 4 n. N is the number of year, so that's the year. So you may say, wait, there's two unknowns. How do I do that? Well, there's not two unknowns because P just cancel out from the beginning. You can divide both sides by P. Then, well, since this is a calculator paper, you can really just do n solve on this to find n. Right? That's the point of doing calculator paper. But in case you're wondering how do you do this using some math that you know, since the unknown is on top in the exponential, you should log both sides. So this is if you want to do it by hand. You don't have to. If you log both sides, the power can drop to the front, so the 4 can drop here. So we just divide this whole thing away. Log 2 over log that number. What's the number? We got that before. Okay, it's 811 over 800. If you use a fraction, 4n. So divided 4 as well, you get n. So we obviously need the help of a calculator to divide by log base 10 divided by 4. So n, I got 12.689. So basically you need 13 years. So let's find the year that this happened. You started at 2020, you add 13 years. That should be 2033, I think. Yeah, probably. Cool. Question 3. Next, question 4. A 6-sided dice, which is not fair. It's a biased dice. Probably getting a 67 over 10. Toss it 5 times. Round probability. Okay, this is obviously binomial distribution. Hope it's obvious to you. The number of trial is 5. Success probability is the probability that you get a 6. So A is the probability that X is at most 3, so it's less than or equal to 3. This is obviously something you can do with GDC. Typical calculator. You go to statistics, distribution. You go to binomial CDF. It's a CDF because it's less than or equal to. Okay, so if the question wants like exactly 3, you do binomial PDF. If it's an inequality or a interval, then you do CDF. So I'll do that. I won't show you my calculator. Should be, especially if we use a different brand, doesn't help you that much. So the key is to do binomial CDF. So for mine, they ask for number of trials. That's n. That's 5. N. That's n. N is 5. Your input 5. Success probability is this. My calculator would ask for lower bound and upper bound. So that's 0 to 3. So lower bound is 0. Upper bound is 3. Okay, you should get 0.47178. Okay. If the question doesn't specify, you can write more than 3 sig figs. You wouldn't be penalized unless they say specifically how many. The third 6 is on the 5th toss. Okay, think about that, what it means. Okay, that seems a little bit tricky. Yeah, you should really pause the video now, give it some thoughts. Okay, hope you can try this yourself. Okay, answer will be coming. 3, 2, 1. So you want your third 6 to be on the 5th toss. So that means you throw it 5 times. So you mean at the fifth times, you first of all need a 6. But you need this to be your third 6. What does that mean? That means within the first 4 toss, there should be 2 6 somewhere around. Okay? So how do you get this probability? Well, for that part alone, that's a binomial distribution. That's a binomial distribution where you only have 4 trials. The success probability is still the probability that you get a 6, so it's still 7 over 10. But within the first 4 trials, you need 2 6s. Okay, you need 2 of them. Okay, that should be a y. Okay, and then you need another 6 at the end. So the probability of getting a 6, 7 over 10. So you multiply by another 1, another 6 there. Okay, this, as I said, would be binomial PDF, except the number trial becomes 4 this time. So 4, 7 over 10, 2, got 0.2646 times 7 over 10. I got 0.18522. All right, there. That's number 4. Number 5, regression line. Well, very calculator dependent. Yeah. Okay, but be careful, this time they want the regression line to be x on y, which is a bit untypical. It's usually y and x. So when you do it with your calculator, you need to be slightly more careful. So most likely with your calculator, you would first go to mine is called a spreadsheet. Go to somewhere you can input the data. So I'll do that. So x, input the x. Then you input the y. Okay. And then you should go to like some statistics calculation or something, and then look for regression line. So they want it to be x on y, but most calculator would give you the regression line as y equal to mx. I mean m. Why do I write 3? mx plus, they usually use b. Okay, but the question wanted to be x equal to ay plus b. That simply means for the y you should input x, and for the x you should input y. Okay, so when the calculator asks for the x values, you should tell the calculator that that's the y values. You should put the y values into the x values. So in my case, that's b. And for the y, put in the x. And you should get the equation being 1.29 for 3 sig y plus, b is negative, minus 10.379. You should get this. So a is 1.29, b is negative 10.379. Okay. Now L2 is the regression of y on x. L1 and L2 pass through a certain point PQ. Find PQ. Okay, well, there's two ways to do it. You could find L2 as well. Okay, where this time you really put y to be y, put x to be x. You don't need to swap them. And then you just solve the two regression lines simultaneously. Then you can find, where they pass through the same point. That's the intersection. You can find the intersection. There's an easier way. Well, no, there's a faster way, which is you should know that the regression line always passes through the mean of each of the data. So it always passes through the points formed by the mean of x and the mean of y. Okay? So you can also just use that. So basically just P is just the mean of x and Q is just the mean of y. So the mean of x would be, obviously use a calculator to help you. To find a mean. Oh, you know how to find a mean, right? So that's basically one variable stat, but you do it on x and do it on y. Okay. The mean of x should be 28.7 through sig fig, and the mean of y should be 30.3 for through sig fig. Therefore, P is that, Q is that. Okay. Yeah, so that's the key. Regression line always pass through the mean. Next, a kinematics question. Nice. They give you the displacement question. What is the maximum distance from the graph? Okay, this is where you should graph the whole thing. Graph the whole thing. So let me graph it. And be careful that when you graph it, use radian. Because for kinematics, where differentiation is potentially involved, you have to use radian. Okay, so one of the things that is difficult for graph is you need to set up the windows. This is the domain. So when you set up the windows, x should be between 0 to 5. Then just give it more y so you can see the whole thing. Okay, when I did it, so this is S, this is T, I get something that look like this. Okay? Question, this is displacement by the way. Question, what is the maximum distance? Is it just here? Well, the answer is no. The maximum distance is actually this, the minimum. Okay? The reason being this is displacement. Distance is the magnitude of displacement. Okay? So what it meant is here maybe the displacement is 2 and maybe that's a maximum point. Let's say it's 2. It's not 2. We need to find it, but let's say it's 2. But the minimum here is maybe minus 5. But that's for displacement being minus 5. For the distance would be the absolute value of minus 5, so it will be 5. So this point would have a larger distance than this point, right? Because distance doesn't care about the negative. So it is this point that gives you the maximum distance. So on your GDC, you should look for the minimum instead. So that should be easy. Analyze minimum. Depends on your calculator model is a bit different. My calculator is very slow. Okay, I got negative 16.5. So the maximum distance is actually 16.5. Okay. B, find the acceleration of the particle at the instant that it first changes direction. Now, when do your particle change direction, right? Your particle change direction basically means that you were originally going to the right and then you suddenly go backward. Okay, that's changing direction. And if you are going right, your velocity is positive, but if you're going back, your velocity would be negative. Okay? So at the moment that you're changing direction, your velocity should be 0. Okay? So the first instant that you change direction is the instant where the velocity equal to 0. Okay, so seems that we need to find out when is the velocity 0 for the first time. Okay, when is that? If you think about it, the velocity is the derivative of displacement. Okay, that's the definition. Okay, so if we want the velocity to be 0, that's the same as saying we want the derivative of displacement to be 0. Okay. Now, when would a derivative be 0? Okay, we have the displacement graph here. When would the derivative suddenly be 0? Well, the answer is at the maximum. Okay, so the first time that you change direction must occur when the maximum occur. That's the first time that the derivative is 0. So that means we should find the maximum. Let's find the maximum. So the maximum is useful after all. Okay, for me, the x-coordinate of the maximum is 1.52, okay? This time we're caring about the x-coordinate, which is the time. Oh, yeah, of course. Why do I write that to be t? That's wrong, Yeah. Yeah. Okay, so the time for it to change direction for the first time is actually 1.52. Now I need to find the acceleration to that. Okay, how do you find acceleration? Well, you find acceleration by differentiating this twice. Oh, but it would take quite long to actually do it. Can our calculator help? The answer is yes. Very likely that your calculator would have the function to differentiate. But calculator only can do numerical differentiation, so you need to tell the calculator at which x you want to evaluate your derivative. But acceleration is the second derivative, so you need to tell the calculator to differentiate the thing twice. So basically type in second derivative, you choose second derivative in the calculator. So if it's 1.52, and then you need to type in the function. So you need to tell the calculator you want a second derivative, okay, and type in the function. So the function is, should I get more decimal place for the time? Technically, yes, because this is within the part. This should be, if you get more decimal place, it should be 1.5198, blah blah blah. So you do that, so the second derivative of this is what you would type to the calculator, depending on how your calculator do the second derivative function, with x being 1.5198. You just type this in. Should be that your GDC would do it. And if you type in the whole thing, you should get negative 8.92. Okay, so that's the acceleration. Okay, so the key of this question is you don't need to do the second derivative yourself. For GDC, they can find the derivative at a particular point of x They can tell you the value of the first derivative and second derivative. Okay, that's the key. So that should conclude section A.